Our advantage was slipping away. Chain home could warn of attacks, but it couldn't guide night fighters, couldn't fit on aircraft, couldn't detect submarines, couldn't provide bomber navigation. But what the Americans didn't know was that two physicists working in a Birmingham basement had already solved the impossible problem.
In February 1940, John Randall, age 38, and Harry Boot, just 27, worked in a basement laboratory at the University of Birmingham. They'd been given an impossible assignment: create a microwave generator powerful enough for practical radar. Neither man was a radar expert. Randall studied phosphorescence. Boot was fresh from his doctorate. They'd been assigned this project almost by accident, because senior scientists considered the problem unsolvable. But sometimes the best solutions come from people who don't know what's supposedly impossible. Previous magnetrons used a split anode design: a cathode in the center, cylindrical anode around it. High voltage and magnetic fields made electrons spiral, generating radio waves. But controlling frequency and generating power proved nearly impossible. Randall and Boot asked a different question. What if the tube itself determined the frequency? They designed a solid copper cylinder with a hole drilled through its center for the cathode. Then they drilled additional holes, resonant cavities, in a ring around the central space. These weren't random holes. They were calculated resonators, like organ pipes, tuned to specific frequencies. The cavity dimensions would determine the microwave wavelength. The concept was elegant. Electrons spiraling past these cavities would naturally excite oscillations at the resonant frequency. No external control needed. Self-organizing physics. But building it was brutal. They had no precision machine shop. Early prototypes were cut using Colt pistol jigs borrowed from a local workshop. Yes, revolver cylinder jigs. Tolerances had to be perfect. Fractions of a millimeter mattered at these frequencies. On February 21, 1940, they powered up their first working prototype. The copper cylinder, 9 centimeters in diameter, began generating microwaves at 9.8 centimeter wavelength. The power output climbed: 100 watts, 200 watts, 400 watts. 400 watts of continuous microwave power. American klystron tubes produced 10 watts and were 10 times larger.